Assalamu alaikum everyone. Welcome to week 5, lecture 13 for CS116 object oriented programming. So let's get started. Last week we had been discussing inheritance. We did a lot of examples to explore the syntax and see the use, like where we can use this concept. Then we learned how method overloading can be used to extend or override functionality or partial functionality of the parent class. We also discussed how we can make the built-in classes more useful for us by extending them or inheriting from them. In today's session, we'll discuss multiple inheritance. And multiple inheritance means when a class inherits from more than one classes. We'll see what problems does it cause and how to solve those problems. One of the major problem that it causes is which method to select in a hierarchy. When a method is called, how Python selects a particular method from different classes in the hierarchy. For that, method resolution order is used, and we'll discuss that in today's lecture. Okay, now let's first recall this concept from lecture 3. There we discussed that multiple inheritance means when a subclass is allowed to inherit from more than one superclasses. That means a child class can have more than one parent. And when that happens, a child inherits features of all its parent classes. This is the example that we discussed. Father and mother are two separate classes and child is inheriting from both. That means child will be inheriting all the attributes and methods from father and all the attributes and method from mother. Now the problem arises in multiple inheritance when some attribute or method exist in both the parents or more than one parents having the same name. Like here you can see eye color exists in both. So if child class tries to access eye color, which eye color will be accessed, father's eye color or mother's eye color? So every programming language that support multiple inheritance is provides some way to resolve this issue, or provides some search order in which classes are searched whenever a child accesses a method or an attribute. And in Python this is called method resolution order, or MRO. Now the syntax for implementing multiple inheritance is really simple. Let's suppose this is one class called father and it has some attributes and methods, and then there is another class called mother and it has some attributes and method. So if I want to make a third class and I want to make it inherit from both these classes, father and mother, I just have to give the list in these round parentheses. So it's just like single inheritance, but here you just increase the number of parent classes, right? And one thing that you'll see shortly, that order in which you are providing these parent classes is really important in Python, right? So here this child class inherits from two classes, father and mother, and father has been placed towards the left. So I'll shortly show you what does that mean, or what difference that does it make. Okay, then this child class can have its own attributes and methods. So there is nothing special about the syntax. You just put as many classes, as many parent classes as you want in these round parentheses. Now this is the feature of multiple inheritance. Like when a child class inherits, or when a class implements multiple inheritance, it inherits attributes and methods from all the parents. So the example that I'm going to implement here will show you this, or will prove this point. So in this example, I'm going to implement this scenario. Here you can see we have three classes, class A, class B, and class C. And class C is inheriting from both class A and class B. So let's write some formal code to implement this. So first I'll define the parent classes. So here's my first parent class, class A. In this class, I'm defining only one method, and this is called method A. And I am printing something here in method A, right? So this print statement is an indication that this method A has been executed, right? So this class A contains nothing else, it only contains this single method A. Similarly, I create another class B, and I define a similar method with the exception that it prints the message in method B. So this method again will be an indication that we are accessing some method of class B or method B of class B. Okay, now I want to define a third class C, and I will inherit this from class A and class B. That means A and B will be given as brackets here, right? So will be given in brackets like this. So class C is inheriting from both classes A and B. And here I'm including again only a single method, and this method will indicate that we are executing some method of class C. So now if I instantiate an object of class C like this, that means this object is inheriting all the methods and attributes of the parent classes. So that means method C is accessible because that is part of class C. Apart from that, method B is also accessible to object C because class C is inheriting that object. And again, method A is also accessible to object C because C is inheriting from A. So object C is an object of C type of class C, but since it is inheriting from A and B, all the methods of classes A and B, they are also accessible to this object C. And to prove this, let's access these methods. First of all, I'm accessing method A. So when you run it, it won't produce any error. In fact, you will be able to access this method without any problem. So here's the output. This means that method A has been executed successfully. Similarly, I can call method B, which is from parent class, from the second parent class. That is also accessible. And here is method C, right? So this is almost the same as with single inheritance. The only difference is that we have now we have more than one parent classes. Okay, now there is one more way to check this. I can use that directory function on this object C. So here I am calling dir on object C, and this is the output that it produces. Now here you can see a list of methods. Although we defined only one method in C, one method in B, and one method in A, but there is a whole list of methods here. And from where all these methods are coming? For that, let's see the hierarchy. First of all, we have class C. This yellow color indicates that only method C belongs to class C. Actually, this color coding has been done by me. Of course, Python doesn't show you the output like this. Okay, then this C class is inheriting from two classes A and B. So class A is in green color, and that green color method A means that belongs to class A. Similarly, red color belongs to class B, method B belongs to class B. And I hope you remember from where all those remaining white methods are coming from. They are coming from the class object, because class A and class B, they both are inheriting from class object by default. We are not making them inherit from any class, so Python make them inherit from this class, this built-in class object, right? Now you see this structure, it looks like a diamond. So this is called the diamond pattern or diamond structure, right? And this is a significant structure. We'll be discussing this in later on in this lecture. So you just keep in mind, diamond structure means this kind of a structure. One class at the top, then it expands to two classes, and then the pattern comes back to a single class. So it makes a diamond, right? So here this directory function also proves that class C, which is the child class of A, B, direct child class from A and B, and indirect child class from object, it inherits all the methods from all of its parents. So this example showed that implementing multiple inheritance is as simple as implementing single inheritance. But there is one issue with this technique, multiple inheritance, which makes it an unfavored choice for programmers while making a program. And the problem is this, that when a method having method or attribute having same name exist in more than one parent classes, in direct parents or in hierarchy. So if the same name exists in more than one parent, then which method or attribute will be accessed by the child, right? So that is an issue. And let's see what how Python decides which method to access, right? So I'll show you a couple of examples first, and then after seeing those examples, we'll summarize the method resolution order. Okay, now this is example 1. Here, consider this hierarchy. This is the same hierarchy which we did in last example. Here, class C is inheriting from two classes A and B, and if you remember, we put class A on the left hand side in parentheses. So what's the search order here? Whenever a method is called on any object of class C, first that method is searched in the current class, that means class C, and then we move up the hierarchy. If it is not found there, then we move up the hierarchy. It is searched in the parent class which you specify as the leftmost class in parentheses. Now that I just told you that that order in which you specify the parent classes is important. So left parent has more priority as compared to the right parent. So if an object is not found in the current class, then it is searched in the left parent first. If not found there, then it is searched in the right parent, right? So let's test this. Now, in order to understand this, or in order to test this, we'll consider different cases. The first case that I am considering is this, that there is a method, whatever its name is, here I'm taking it as method, and it exists in all the three classes A, B, C. So this is the scenario. This method exists in class A, in class B, and class C. So name of that method is same. Now let's start writing the code. In class A, I'm implementing this method by printing this statement in method A. This will indicate that method from class A has been executed. Similarly, for class B, I'll implement the same a method with same name, but it will print a different message, and this will indicate that we are in class B. And lastly, in class C, we'll implement again this same method, but here we'll print in method C, right? Now let's instantiate an object of class C and try to access this method. Now this method exists in all the three classes, and according to the search strategy that I explained on last slide, method of class C should be accessed, right? That means that it will first search the current class and it will find that method in the current class, so it will not go up the hierarchy. So the expected output is in method C. Here it is. Okay, now this is case 2. Here we are not implementing that method in class C. So this is the scenario. Now let's see which method is accessed. According to our strategy or the search strategy that I explained, class A's method should be accessed because class A was placed on the left hand side. So let's define it the same way. Class A, class B, same method in both the classes. And in class C, now here you see we are placing A on the left hand side and B on the right hand side. So method from class A should be accessed. Okay, here I don't want to include any code. I have excluded that method also from this class, so I do not want to put any code here. So this is a statement that I can use instead, pass. Now I instantiate this object C of class C type, and I call this method. Now again, this method will be searched in the current class, but since it's not found there, there is no such method in class C, so the first parent or the left side parent will be searched. So here it is. So that means that this method has been executed from the leftmost parent, which is class A. Okay, now third example or third case will show you that class B is the last choice. So here is the scenario. I have removed the method from class A as well. So class A doesn't contain anything, class C doesn't contain anything, and class B is implementing this method. So if I instantiate object C of class C type, and I call this method, this will be searched in current class first, that is class C. It is not found there. Then Python will search in the leftmost parent, which is class A. It's not there even, right? So then in the end, right hand side parent will be searched, which is class B. So this should print in method B, right? So if you reverse the order, that inheritance order in class C's definition, instead of A comma B, if you write B comma A, then B will have greater priority as compared to class A. Okay, now let's consider another example. Here, it's not simple multiple inheritance. We are using multi-level inheritance for each parent. So this is the scenario. Here you see class C has two parents, class A and class B. Then class A is further inherited from class X, and class B is further inherited from class Y. So let's see what's the search order here. Here again, if you instantiate an object of class C type, then and you try to access some method which exists in all these classes X, Y, A, B, and C, then first the current class will be searched, right? And if the method is found there, it will be executed, and if not found there, then we'll go to the left parent, right? And after accessing left parent, we won't come to the right parent, but we'll go deeper into that branch. If you do not find that method in class A, then you will access parent of class A, and you will go all the way up the hierarchy, right? Once whole of that branch is covered, then you come to the right hand side, and then you access class B, and then parent of class B, and if there is parent of class Y, you access that, and so on, right? So here you see this is kind of depth first search. Why we call it depth first search? Because you see, you view this as a tree, right? Class C is the root, and it has two branches. One going on the left hand side containing class A and class X, and the other branch going to the right hand side containing class B and class Y. So here what you do when you take up a branch, you explore its depth first. Like you go all the way up to the end of that branch, and then you come back, and then you go or choose the other side or the other branch. This is called depth first search. And we'll consider or we'll see another variant of it, which is called breadth first search shortly. But before that, let's do an example on this and prove this search strategy. Okay, like we did in the last example or example 1, here also we'll consider it case by case. So the first case is when the method exists in all the classes. This is a scenario. Method is a method which is there in all the classes. So let's quickly write simple code for this. In class X, this method will print an appropriate message. In class Y, it will print in method Y. For A, it will print in method A. For B, it will print in method B. I hope this font is not too small. I just wanted to fit it on a single slide. And this is not a very complicated code, so I hope it won't be a problem for you guys. Similarly, okay, along the path, you see class A is inheriting from class X because X is written in those brackets, and class B is inheriting from Y, and class C is inheriting from both A and B. So this is how we implement this hierarchy, which is shown on the right hand side. Right now, I instantiate an object of class C, and I call this method. So according to the strategy that I showed you on last slide, it should access current class first. So it should print in method C. And here it is, right? Here is the second case where this method exists in all the classes except for class C. So this is the scenario. I removed this method from class C. The code remains same for all the 4 classes or all the 4 parent classes. And for class C, I'm just writing pass. Pass means I'm not including any code here, and we instantiate an object, and I call this method. Now, this method again will be searched in the current class, which is class C. But since it's not there, then the left immediate parent will be searched, which is class A. So it should print in class A. And here it is. Okay, let's quickly go through the other cases also. here now I have removed that method from class A as well. Now it is there only in class B, class X, and class Y. So according to our search strategy, now it should access class X. So the code is same up till class X. Sorry, up till class Y. For class A, I have excluded that method, so I'm just writing pass here. Class B's code is same, and class C's code is also same as the last case. So let's instantiate object and let's call this method. It should print in class X, right? Sorry, in method X. Now, in case 4, the method exists in only class B and Y. Now, since this method is missing in the current class C, it is missing in class A, it is missing in class C. So next Python will come to class B. So the code remains same. I've just replaced code for class X, class A, and class C. Okay. Now it should access class B's method. Here it is, and this means that this method was first searched in class C. It's not there. Then it must have been searched in class A, and then in class X, and then Python came to class B, where finally this method was found. And this is the last case. I hope I don't need to explain it much. So I have removed this method from all the classes except for class Y. So Python doesn't have any choice. It will start looking for this method from class C, then class A, then class X, then class B, and finally it will find it in class Y. So is the output, right? So that means in such a tree in which each parent class is further inheriting from any other class, depth first search is the call, right? First leftmost branch will be explored, and then Python will come to the, or interpreter will come to the rightmost branch. Okay, now this is the third scenario, the diamond pattern, which I discussed in the start of this lecture. This is a diamond pattern. Right here, class C is inheriting from class A and class B, and then class A and class B, they both are inheriting from some class. Let's suppose here we call that class X. This is called a diamond pattern because it looks like a diamond, right? That shape diamond. And let's see what's the search order here. Here it's different as compared to the last case. So here again, current class will be searched first, and after that left parent will be searched. But after searching the left parent, it will not go up the hierarchy. The search will not continue up the hierarchy because class A and class B, they both have a common parent. So this time search will be done breadth-wise first. Like if you consider this as a tree with class C at its root, then class C is the first level, class A and class B are at second level, and class X is at third level. So here searching will be done level wise, and on each level search will start from the leftmost class and then we'll go towards the right. So here search order should be would be in fact class C first because that's the current class, then we'll go to class A. After class A we'll go to the right, that means class B, and then we'll go to the peak, class X. So order will be class C, class A, class B, and then class X, right? So this is a different case, and this is called breadth first search because you are searching this tree breadth wise, right? And in the last example, we were searching the tree depth wise, right? So that's the difference. Now let's see an example, a similar example like case wise. So let's suppose this method exists in all 4 classes. Let's quickly do this. I hope you are clear with what I do in these examples. So here this method exists in all 4 classes like before. The code is like before, and you can see the inheritance pattern. Class A is inheriting from X, class B is inheriting from X, and then class C is inheriting from A and B, thus forming this diamond pattern. So now if I instantiate this object, it should, and I call this method, it would be searched in the current class first. So since this method is found there, so class C method should be executed, and here it is. Let's quickly go to the rest of the cases. Second case, I'm removing the method from class C. The remaining code remains same, right? Now, according to our search algorithm, class A should be searched. And here it is. This is case 3. Now only 2 classes contain it, class B and class X. And according to our the rule that we discussed, now class B's method should be executed. So let's quickly see that. Okay, you see I've just removed this method from class A and class C. See, class B's method has been accessed. I feel I don't need to explain this case 4 now. So this is here just for the sake of completion. Now the method exists in only class X, and that will be executed. Now, having seen some examples of distinct patterns, now let's summarize this rule, method resolution order. So what is method resolution order? It is the order in which Python looks for a method in hierarchy of classes, right? And this is important, especially when you have a method of same name in multiple classes in multiple inheritance, especially, right? So let's see what the order is, or what we have gathered from the 3 examples that we just did. Now MRO has 3 rules. First is a simple rule. When this is case 1 actually, when a child is inheriting from 2 classes. So first left hand side class will be searched, and then right hand side class will be searched. And if these parents, they are further inheriting from any classes, then this is the order: depth first, search will happen, right? So this is called depth first, left to right. First you will take the leftmost branch, you will go up to its depth, and then you will come to the right hand side branch, and then you will continue towards its depth, towards the depth. So this is what we saw. And the third rule is for diamond pattern. In diamond pattern, we don't use this depth first search, because in diamond pattern the problem is, if you use this depth first search, then the peak will be executed twice, or will be searched twice. Like if you recall from last example, there was a class X. So if you go depth wise, then after class A, class X will be searched, right? And then after class B, class X will again be searched. So class X will be searched twice. So this diamond pattern, in diamond pattern, we move breadth-wise. So this prevents us from searching that peak class twice, right? So this is the rule. Now let's do some examples on this. Okay, now before moving on to examples, there are certain points that I want you to note here. First of all, that this order, or this search order, it applies to attributes as well as to methods, right? If you are calling an attribute on a child class, that attribute will also be searched in the same manner, or will have those 3 cases. Second, although this is a default search approach, like if a method exists in more than one classes in hierarchy, then these are the rules for default search, like the search done by Python. But at any time, if you want to explicitly call any method from any superclass, you can use that naming technique. We had been using this in for single inheritance. So you can always call any method using the class name dot operator, and then you can access that method explicitly as well. So the order that we discussed is the default order for Python. Otherwise you can access any method at your own choice, right? And the third point is this, that this default order can also be overridden. There are methods in Python by which you can override this method, but we won't go into that much detail here in this course, because as I told you at the start of this lecture, that multiple inheritance is not a very preferred idea. So we do not have to study this in that great detail. So I'm just telling you for information that you can define a custom order as well, a custom default order as well, using this attribute, double underscore MRO double underscore. But you don't have to do that. We have alternate better ways for this as well, which I'll show you in next lecture, in next couple of lectures actually. Okay, now let's see some combined examples, or a little more complicated examples. Here in these examples, I will not write the code. We'll just explore the order. Like we'll see using those three rules which classes will be accessed. So this is the first example. So now I hope you guys can make out using those rules. First of all, current class will be searched. So in this order, first class that will be accessed will be class C. Okay. After that, since these it has two branches, one going from class A and one going from class B, and they both are disjoint, like they are not being connected with each other at some top. Like I just want to say that this is not a diamond pattern, right? So this falls in the second case. So class C will be accessed first because that's the current class, then the left parent A, and then we'll go for depth first search. So after class A, we'll go to parents of class A, and class A has two parents, W and X. So the leftmost parent will be searched first, and then we'll come to the rightmost parent. So class C, class A, class W, and then class X. After exploring this left hand side branch completely up to the depth, we'll come to the right hand side branch, and then class B will be accessed, and class Y and class Z. So the order will be C, A, W, X, B, Y, Z, right? And you can write code by yourselves to test this. I'm not providing you code for this. Okay, this is the second example, a more complicated one. Here, if you want, you can pause right now and you can first work this out by yourselves, and then you can see what explanation I have for this problem. Okay, here again, class C will be accessed first, because if you are instantiating an object on class C, then class C is going to be the current class. So class C will be accessed first. Now here, if you see, here class A is further branching into class W and X, and class B is also branching into class Y and Z. So if you see this tree up till first three levels, this is case 2. But after that, they all are inheriting from one class O. So at the top, it becomes a diamond pattern, right? So the order should be class C will be searched first. After that, you come to the left parent, which is class A. And after that, you will go depth wise, because up till level 3, there is no diamond pattern up to level 3. So after class A, you will go to class W, then class X. And because after that, diamond pattern appears, so you won't go further up to class O now. So after class X, you will come to the right hand side branch, which is class B, then class Y, then class Z, and then finally to class O. Actually, the pattern that we discussed in for diamond pattern, the order that we discussed for diamond pattern, that was there to eliminate double accessing this class O, right? So we'll follow the approach or the second algorithm or the second rule until we encounter any peak, like diamond peak. So up till third level, we'll go for the second rule, and after that, because we have a peak, and what happens if we do not follow diamond pattern for the last one? What will happen? Class O will be accessed twice. So up till third level, we'll follow rule 2, and after that, we'll follow rule 3. So C, A, W, X, B, Y, Z, and O. And again, you can write a code in the same way as we did for initial first 3 examples, and you can test this. This is the third example. It's a little different. What you say, is it a diamond pattern? I don't think it's a diamond pattern, because if you see class C, it has two parents, class A and class X, and then class A has further two parents, W and X. Okay, now here first we'll access class C, then the left parent class A. And if you see from class A's point of view, class W and class X, they are two independent parents. So after A, W will be accessed and then X will be accessed. And since X has already been accessed, uh, Python won't search it again, like as right parent of class C. So this is the order, and this will work, right? This is the last example, and I would highly suggest to pause it right here and then try to guess the order. There is no question about class C. Class C will be searched first. After that, we have class W as its left parent. So let's access class W. Then we'll come to class A, and then class A's parent is again W. So W will be searched again. So this is the expected order. But you know, when you execute this, Python will give you error for this. It will give you this error, cannot create a consistent method resolution order. Now the problem in this order is that if you see, A is child class of W, right? And what is the rule? The rule is that a parent cannot be accessed before its child. So if you see in this pattern, W is parent of A, and we are accessing W after A, but we are also accessing the same class before A as well. So if this ever happens in your search order, then Python will not or Python will give you syntactic error and it will not execute the code further. So this is the reason a superclass cannot appear before a subclass. Now these were the few examples. I know that you can create a lot of different examples from here, like you can mix diamond pattern and that, you know, depth first search pattern in different combinations and make really complex combinations. But I won't encourage you to do that, because we'll be rejecting this whole multiple inheritance concept soon. Not rejecting, but I'll show you that there are better ways to implement the same scenario. So you should avoid multiple inheritance as much as you can, because you see there are complications in there, right? So I hope you are able to grasp the main concept here. In this lecture, I demonstrated how you can implement multiple inheritance. Multiple inheritance means that a class can have more than one parent, right? And this is really fine if you are inheriting a class from two parents which are really distinct from each other. But the problem arises when the parent classes, or direct parents or indirect parents, they contain some method or attribute which have the same name. Then Python follows MRO, which is method resolution order, to resolve this issue, like how like to decide on the search order, right? And that search order sometimes creates problems if the hierarchy is too complicated, right? So this is what we saw today. We'll talk about this more in the next lecture. Thank you.